So it is today's daily question: minimum string length after removing substrings. So we'll be given a string S consisting only of uppercase English letters. Then we need to apply some operations to the string where in one operation you can remove any occurrences of one of the substrings AB or CD from S. Then return the minimum possible length of the resulting string that you can obtain. So note is the string concatenates after removing the substring and could produce new AB or CD substrings. So this is an important note for us. Let's understand this with an example. So in the first example we're given, so okay, I'm writing in lowercase letters C, A, C, D and B, right? So in these letters, what we need to do, we need to remove occurrences of A, B and C, D. But in the very naive solution, if this note is not given, then what we'll be doing? We'll be just like traversing this array, this substring, and we'll be noting AB as a one thing and CD as a thing, and we'll just remove this and print FCAB. But in this note, what I have given is after concatenating the removed substring, if it forms an AB or CD, then we need to remove that also. So as you can see here, after removing CD, we'll be getting FCAB here. So we need to remove AB also. So what could be the very brute force solution for this? We can just use two pointers like kind of approach. So let me write that again. D and B, right? So in one iteration, you just find out whenever you got AB, remove it, and then in the second iteration, what you will be getting is F, C, A, D, B, and is that right? F, C, okay, A, C, D, B, and in the second iteration, when you encounter CD, remove that also, and you will be getting F, C, AB, and in the third iteration you will be getting AB, remove that also, and it will be FC. So it is a brute force solution in which we'll be using two for loops. So it is like for I in range length, we'll be traversing the length, and whenever in the other for loop, we'll be traversing the substring to find out whether we got an occurrence of AB or CD or not. So here's how we can do that. So this is very brute force naive solution. And the second approach would be like, here you can see. So the second approach is based on stack. So the given A, B, F, C, A, C, D, B, like kind of things, right? So in this previous approach, the time complexity would be big of n square, and the space would be big of 1 because we're not using any extra space, we're not creating any array. But the time is n square because the first loop will be traversing the entire array, and in the second loop we'll be traversing if the words are at the end, then we need to traverse the entire array also, right? So it would be kind of n square. So the second loop is for removing. So for removing, it is definitely n square, right? So that's kind of, so let's just, yeah, using stack, how we can achieve this? We need to optimize the solution from n square to the 1. So how could we achieve this using stack? The data structure we'll be using is a stack, but how do we get this intuition? So we get this intuition because we're comparing the side uh, adjacent one, and after deleting that also we're concatenating it. So using a pointer, we're dividing the substring into two types. So let's say that I'll just erase these all and write in a stack. We have A and we got B here. So this is a condition. When we got this condition, when the top of the stack is A and we got a B here, we'll remove these two. And then next we encounter F, there is nothing to do, we'll push it into stack. Next we get C, nothing to do. Next we got A, nothing to do. Next we got CD. So until here the top of the stack would be C and the current element we'll be pushing will be D. Then it is like CD, so we need to remove it. So just remove it. Next we'll be encountering B. So the top of the stack is A and the current element we're trying to push is B. So just remove these two also. And at last the stack will be containing FC, only these two elements. So it's kind of stack based solution, right? So that's it. This is FC. So the next approach would be using in place stack. So it's kind of a array problem because in most of the languages we can't change the string, right? So first approach is big O of n square, and after that the second approach we got time is equals big O of n time complexity and space also big O of n because we're creating a stack here. And in next approach, the next approach we are dealing with, it is kind of array problem. So when this approach to be discussed in the interview, first we need to ask the interviewer that whether I can able to change the string or not. So in other words, we can say if the problem is given in form of arrays instead of the string, we can use this approach. So let's draw the array now. Yeah, this array. So you can see first we got A, then we got B, then we got F, then we got C, then A, B, D. I think this is a string and we need to remove A, B and C, D. So here we will be using the approach of two pointers where we'll be using I pointer for writing and we'll be using the j pointer for reading. So how do we got this approach? Because if you carefully observe in our stack solution, so here we are deleting some pattern. So here we're deleting the AB pattern or CD pattern, right? So why don't we put it like this? So we're only comparing the two elements of a stack. So if we got some pattern, we are popping out the elements from the stack and we are moving into the stack if we got any pattern, and if we didn't recognize any pattern, we are keep on adding into the stack. So in other words, we can say that in the kind of two pointers, if we got any pattern of AB or CD, we are moving the pointer backwards, and if we don't got any patterns recognized, we are moving the pointer by reading. I mean, we are moving the pointer towards the string or array. But the real problem is, how do we memorize? So in the stack kind of things, we're popping out and we're having the exact array. But if we using the array here, we should delete some of the things. So this kind, like here, if you just see this AB pointer here, how can we delete this and memorize CD are there to the adjacent of this? How can we do that? So let's go with the dry run and understand. So here we have I pointer and also the j pointer here. So if we got these two, first figure out I pointer is at B and j pointer, I pointer is at A, j pointer is at B. So it is the pattern. We are using only two pointers because here we have only A, B and CD, right? So if these two are making pattern, then we need to delete it. How can we delete this? We just don't need to do anything. So, so, erasing. So just make sure the I pointer is at index -1, index 0, 1, 2, 3, 4, 5, 6, and 7. Now we got A, B, right? So just move the J pointer here. A, B, we're deleting them. So just delete these two. And now we got F at the J pointer. We are reading F. And does I have anything? No. Then F is the first character. If F is the first character, then I should place to the first character. So now increment the I and write here the F. And now just increment the J pointer. Now I pointer is at F. We just overridden this. We have overridden the A pointer, the index 0 to F, and when we increment J pointer we have C, and after comparing I and J we have F at I and J at C, so it's FC, it's not a pattern. So what we'll be doing, if it is not a pattern, then I pointer should place at C. Then increment the I pointer and update this first index also. FC is a valid string. So now we got A here after incrementing J. So now the pattern is CA. CA is also not a pattern. Then just increment the I pointer and update this F to, so let me write this. Should erase, why it's not erasing? So it should be like A now. I pointer will be placing here. Next, here we got J. Just increment this. Now I pointer is at A, J pointer is at B. It is making a pattern. Then we need to decrease. I mean, we need to remove this from our consideration. Until now, we have considered F, C, A, and now we are deciding we should consider B or not. As we recognize a pattern A, B, we should not consider them. Then what we need to do? In the case of stack, we'll be popping the A. So if we pop that A out, then what will be happening? I pointer will be decremented because, as I said before, while removing elements from the pop, in the sense moving backward to the array, so decrement the I pointer, and we also don't need this B. So just next part would be D, and now compare these two. The top of the stack is now C. That means the I pointer is placing at C, and now we are deciding whether we need to consider D or not. It's making a pattern CD, so we should not consider. So just remove that. Remove this C also. CD. Now we will be left with only I pointer will be decremented and J pointer will be at 7. So we have nothing. So the string length is only 6th index. It will be out of index and loop will be completed. Now our ith pointer would be at 0. 0th index. 0th index in the sense plus 1. The length is 1. So we got the answer 1. So this is the approach for this problem.